is about representing recursive routines with graphs, tables, and words. So application problems. So please set up your notes, and the goal is represent routine applications with graphs, tables, and words. And have a section for questions and a section for conclusion. If you'd like, you can draw a little stick figure sketch. We've got a picture of the subject, Matt, of our first problem. And Matt has a payment plan for his texting. So Matt pays a fee for texting of $25 per month as what's called a base rate. That's what he pays every month, no matter how many texts he sends. Then, on top of that $25, he pays 15 cents for each text he sends or receives. We've been talking about recursive routines, and we can see this fee, these fees, as a recursive routine. The start value of this routine would be if he sends 0 texts. If he doesn't send or receive any text, the start value is how much he's going to pay per month. So see if you can write down the start value. That is how much he's going to pay per month if he doesn't even send a text or receive a text. So his start value is going to be $25. Now, let's think about the operation. If he sends 1 text, what's his total fee going to be? Well, we would add $25 plus 15 cents, and that would be his bill. So the operation is going to be to add 15 cents. So let's make a table. On one side of the table, we're going to have the number of texts, and on the other side of the table, we'll have his total bill, how much he pays monthly. So I'll just make this a little bit bigger because it's a little hard to read. So that's his monthly bill on one side and the number of text. So if he sends 0 unreceived, sends or receives 0 texts, his bill is $25. If he sends 1, it's $25.15. Fill out for 2 texts, 3, and 4. If you want to stop the video to work ahead a little bit, you can go ahead and do that. So each time we're going to add 15 cents. Notice that our counter is not number of months, it's number of texts he sends or receives. So if he sends 3 texts or receives 3, it's $25.45. And I didn't put in 4 there, but it'd be $25.60. Okay, I'm going to stop right here. And our next example says Shasta owns 10 baseball cards. Each week she plans to add 6 cards to her collection. So I would like you to write this part right here where it says Shasta owns 10 baseball cards. Each week she plans to add 6 cards to her collection. Write that and then put an A, but don't write these instructions. Follow these instructions. You're not going to write create an input-output table. You're going to create the input-output table, and here it is right here. And again, you're not going to write create a scatter plot. You're going to create a scatter plot. So you're going to have to get a ruler. And at the end, we want to determine how many weeks it will take before Shasta has 76 cards in her collection. So we're going to be coming up with a shortcut so that we can skip up and we don't have to write a gigantic table. So if you need to back that up and to read those, then go ahead and do that. So Shasta owns 10 baseball cards and adds 6 cards to her collection each week. So the start value is 10 and the operation is to add 6. So we'll start with 10 at 0 weeks. This is similar to the problem that we did with the shot put. So after each week we add 6 more. So after the first week it's 16, after the second week it's 22, and we just keep adding 6. That's our recursive routine. So B, we create the input-output table. I'm going to stop it right there. You created the input-output table. That's this right here. So don't go any farther until you've finished that. So our start value was 10, and our operation is to add 6. Next, we're going to create a scatter plot that shows the number of cards in Shasta's collection over the first 5 weeks. And we have to label both axes. An axis, this is an axis right here, and this is an axis. They're the lines that go either horizontal or vertical. So along the bottom, we're going to label number of weeks. If we have time, we almost always have it go along the horizontal axis. So this is 0 weeks, 1 week, 2 weeks, 3 weeks, and so forth. Along the side, we're going to say the number of cards in her collection, and that would be the total number of cards. So at 0 weeks, she has 10 cards. This is where we used a sticky note before. We're not going to do that today, but we put it right here. After 1 week, she'd have 16. After 2 weeks, she'd have 22. Now I'm going to stop right there and point out that this is 20, this is 25, so I had to estimate where the 22 was. It would go over between the 20 and the 25. 28 is between 25 and 30, so I had to estimate where it was. But it is creating a straight line. If you use your ruler, you should be able to make a straight line. And then finally, we're going to have to come up with a shortcut to determine when, after how many weeks she'll have, how many weeks it'll take for her to get 76 cards. So here's our shortcut. We're going to take the start value, and we're going to add 6 times the number of weeks. So we'll just put X for the number of weeks, because we don't know how many weeks it'll take to get to 76 cards. So X represents the number of weeks. And at this point, we don't know what that is. But we know the total that we want. The total is 76 cards, so we can replace the total with 76. And I just want to check my shortcut to see that it's working. So after 2 weeks, using my shortcut, I should get to 22. So that works. Maybe I'll check another one just to make sure. I guess I didn't do another one, but you could do another one if you want. So now I'm going to replace my total with what I want, which is 76. And now we have a two-step equation. There was a number. At this point, I'd like you to try to work ahead and solve this equation. So if you need to stop the video and do that, this would be a really good time, since you probably have enough experience with two-step equations. But now I'm going to finish it. So there was a number, it was multiplied by 6. 10 was added to it, and it became 76. So we subtract 10, we get 66, and then we divide by 6 and get 11. So that means that after 11 weeks, then Shasta should own 76 cards.